Okay, it looks like we are live. Hello, everyone. This is Postgres TV, Postgres Hacking 101 with Andrei Borodin. And today, I'm Nikolai from Postgres AI, the host of this channel. And today we have an additional guest, Kirk. Hello. Thank you for joining. And the idea is that we will be writing, actually Andrei will be writing a small patch that Kirk proposed last time, and this is ULID function, which is supposed to be helpful as a replacement for regular UUID, and of course as alternative to regular sequential big integer allocation. I will start first of all. If you need surrogate keys, you never should use 4-byte integers, right? Because or do it, and then you will need help from folks like guys from my team to convert your 2 billion rows table to 8-byte integer. But UUID, let's discuss first of all why it's a good idea to consider alternatives to UUID. UUID is like, it looks like it's very randomly allocated. It goes to, if you have many shards or many partitions, the new row will be in some random place, right? But ULID, Kirk, maybe you will explain it better.
Yeah, so, and this comes from Dave Alley. There's a link I sent, which should show up in the notes. So the challenge is that UUIDs are really random, and the amount of IO to insert into a B tree type structure, especially something in the past, causes a lot of read activities because you have to read back there to find out where it goes, and then it splits those trees. So it causes lots of write activities. Sequences have all been optimized, date stamps, et cetera, have all been optimized for what we call right-hand expansion. Every time you add a new timestamp to a series in an index, it goes to the right. It can't go to the left because it's currently, it's a current timestamp. So what happens is you don't split your tree nearly as much, and all that's been optimized. Sequences work this way. So what we want is we want the best of both worlds. We like the UUID because it doesn't tell anybody anything about our system. For example, one of the big companies that did resumes, they got hacked because they used regular IDs in their keys. And within hours of publishing an API, companies realized this and looped through and just provided the ID sequentially for every possible resume they had. And they stole all the resumes out of their system, like that fast, and nothing they could do about it. By using UUIDs, you make that impossible because you'd have to craft accurate UUIDs, not just sequences. But again, the UUID starts suffering.
I just want to note to make a small note that UUID is not random, is not cryptographically random.
Right. Right. Yeah, it's not exactly. And there's variations of this. There's a UUID 7, which is sequentially sortable, right? And it has some extra, features like this where they actually put like a timestamp in the front. So this is where you come around to this idea of, okay, I want a random key that I can use. And everyone sees in these APIs, RESTful APIs, for example, you literally see these IDs as part of the API structure, which is great. You can pass them around, and it's better than using just a number that people can guess at. But it does have this problem where once you get billions of rows, okay, and you start inserting these in a bulk way, you're really damaging your index structure. So the best of both worlds would be, could we have something that looks like a UUID and is right-hand inserted? Meaning it always inserts to the right, so it doesn't keep reworking the entire index structure that we're working on. Also, the advantage is, if it was tied to a timestamp value as it inserted to the right, then you can actually use this as an order by, and you get it out in the order of timestamp. So you can sometimes substitute this and not actually have to have a timestamp sortable field on top of your index ID, which is, again, their article by Dave Alley wrote this, but he only went down to milliseconds. I tweaked the code to make it go down to microseconds, okay, which is available today. The question that I have is, during testing, it's twice as slow as generating a UUID. And part of that's because I'm using an interpreted language, right? So this became the root of, wow, well, what if we code this in pure C code and we apply it the way you would put it, just like the UUIDs are generated? How much benefit will we get if we do that? It should be at least 50%. So I'm thinking it's going to come back out and be an even wash on that. So this gives, from a tutorial for new people trying to understand why we do this, the goal was to come up with a full package that may get accepted by the Postgres people and published, and great. So this is how you do that. And so we're learning that, but we're also going to learn how we can measure the impact performance differences of 2 or 3 implementations, which I think is a great lesson for everybody. So I'll step down.
Thank you, Kirk. A lot of information. I would try to structure it in 3 parts. So first is, I would say, let's postpone performance discussion a little bit. And first part is, Andrei said cryptology. How to say?
Cryptography random numbers.
So in
ULID
Postgres
is not cryptography random.
Right. You
based on start, but in Postgres implementation uses strong random.
Right, but a random function in Postgres is predictable. If you know one value, you can predict the next value.
No,
before
it actually uses strong random function with external entropy, with external source of entropy and cryptography implementation.
I remember an article.
It's kind of not safe by standard, but safe in Postgres. I think so.
I will double check after.
But double check if you do security from this.
I remember an article from from one Russian guy, and it wasn't Russian, and the article just provide the function. You know one value, you can predict next value. Okay, I will double check. Maybe something changed, but I also remember how we didn't pass some security audit because we used random to allocate IDs, I think, or something. And we needed to switch to PGCrypto, better, slower but better implementation. Okay, security. Let's leave it aside. But about performance. So performance of generation of function itself, it's interesting. But I would like to agree with you that if new rows come to one page most often, or a few pages, it's about number of buffers we use when we read, for example, fresh 25 or 100 items, and if they are stored together, it's of course more it's beneficial to store them together, right? So we have a trade-off here: predictable. How predictable is next ID? If you need this, and also how we would like to store them together, new items. Also, it's good for partitioning. For example, old items go to some old partitions and vacuum freeze finished, and we don't need to touch them. Visibility maps are always up to date. We don't all visible, right? So it's great. But sometimes we do need to balance. For example, if we have sharding on Postgres, it's tricky. But we would like to have new item coming to maybe next shard, or absolutely randomly balanced. So this is my understanding. But I agree, I would like to have this function right in core without any extensions. And let's try to
tutorial. It's okay to make it in core, but actually convincing people that we want
as usual
function in core that is not real RFC. It's not a standard. It's close to standard, but it's not. And that makes a lot of sense for core team. So let's do the function so we can use it, and then look what we can propose. One thing that bothers me is that actually acquiring real time is a syscall, which cost us about half a microsecond, and this is costly even in C. But let's see what we get in code, and
Which
So
call?
how to get the code? Yeah.
Which call are you concerned that takes half a millisecond or something?
System call for acquiring real time. It is like call to kernel.
Yeah, clock time. Clock time. Got it.
Yes, but let's measure and see what we can get.
All right.
So you send me the link.
I sent. We will try to use Gitpod with sharing. I've sent it in Zoom chat, and I wanted to mention that indeed, like convincing PGSQL hackers, it's difficult. And I've sent after our last session, I've sent proposal for that small patch Andrei wrote last time. And of course, Tom Lane already said many times it was proposed and it was rejected. I don't see why it shouldn't be rejected this time, but I still see some small opportunity to convince. So I'm going to raise some arguments and try to convince that it's needed. With this patch, we also have low expectations in terms of bringing it to core, but I would try because I think users would benefit from having this. But we will see what Tom Lane will say, right?
So I can share my screen with
Gitpod. Today it's working, I guess.
Yes, I connected to Gitpod. Do you see?
Yes, it's compiling.
It's compiling. Do you know how much time it will take?
It's compiling our transaction timeout patch, so you can stop and switch to the master branch.
Can I get a Kirk's patch with documentation?
This is what I tried to explain before our call. So my extension is working only on postgresql.org. So I need to upload it. Actually, I could do it in Wiki, but no, at this moment, it was not so simple, unfortunately.
Maybe I can just a moment.
We can just copy paste it because it's just.
Yeah, I will just copy paste it from Vim or its IDE. Just a moment, I will find this patch.
My patch was generated from my local machine. You won't.
That's totally fine.
Oh. You just use the patch itself. Got it.
Kirk patch diff. Okay. And then I can I copy paste it wrong. Copy. That's it. I think we will be able to apply it. Can I have one more terminal? Yes. We will reset transaction timeout. Patch checkout dot. I'm not sure if it's visible in translation what I'm doing. Is it okay?
That's fine.
Git apply. Where did I save it? Workspace, Postgres. Workspace, Postgres, Kirk patch. Yeah. And now we see that patch is documenting new get random UUID function, and we want to implement it. It is documented near gen random UUID. Let's search for gen random UUID. First of all, we have to copy the definition. Here is a system catalog. If you create the function in extension, you are defining it with SQL. If this function is created in system catalog, you have to provide it in so-called BKI. I do not remember how it is decrypted. So let's just define our new function, get random ULID, and it has the same attributes as get random UUID.
Yep.
And then we will provide implementation. Here is the C code.
Andrei, can you make a little bit like bigger font? Maybe I see it's, yeah, thank you so much.
So let's take it. And so what we see here, we see allocation of 8 bytes and initializing it with strong random and setting version. Do we need to set version in ULID? No?
No.
What do you think? Let's just comment it for a while, and maybe if we need it, we will return it.
Did you duplicate? Are you going to copy and paste this function before you change it and then change it to ULID?
Yeah, I already duplicated it. So here is a origin function UID, and this is a copy.
All right, you got a typo. Just UU, it's ULID. There you go.
ULID.
Perfect.
And what we can convert it to chars. How many bytes do we leave for timestamp?
That was in the that was in the PSQL code. It was 14 bytes. It's padded to 14 with a 0 on the left. So,
but it's 14 of decimal or hexadecimal. 14,
it's 14. Yeah, that's so I use 9 bytes of random is how many bytes of random I use. So we're going to use everything prior to that. So whatever it has, it's that minus 9 is what we're using for the left-hand side, and we're using 9 for the right-hand side. I don't know the easiest way to say that.
Okay. So we get 9 bytes of random. This is +7 and -7. Actually, we should provide some preprocessor macros for this, but I think this should work. And also we need a function which we can take in clock timestamp. Here is implementation of clock timestamp. It is calling get current timestamp. Let's find a definition of this function. Where is it? Yeah, here we go. This is the definition, and it's calling get time of day, which I suspect is actually a system call. What is result here? Result is timestamp tz. Okay, let's get it to UID. And it's not result for us, it's just the TS. And what's the size of bytes in timestamp TZ?
16, no? Or 8? 16, I guess.
There is a lot of type div.
There's also a function get current timestamp, no? Like camel style, no? If
I just want to copy bytes, some bytes out of timestamp TZ.
Right.
Yeah, I copied get time of day from there.
Okay. We don't need it in full, right? We need only part of it.
So it's actually just number of microseconds. Yes.
Yeah, that's what we want anyways. We actually want the number of microseconds.
So we can just define it as uint 64, if it's okay. And like that, this should work. Timestamp as a number of microseconds. And finally, we need to do byte swapping. Now we are in host endianness, so it's actually little endian. So small microseconds are in the first byte, but we want to reverse it.
Okay.
To do that, we need a function which is called PGCrypto. I think it's PG byteswap. We need to open this file. But how to do that?
You can navigate, right?
I cannot. I can navigate locally, but when I'm doing it in online version,
yeah,
I can do it. So here we have a definition of byte swapping. We have a host to network. This is a function host to network, which is converting endianness. On big endian machines, it's identity function, and on little endian machines, it will do byte swapping. So we need to do byte swapping for TS is how it is usually called. Yes, it just returns result. And also, like here we leave 7 bytes, and now it is 8 bytes, and we want probably we want to remove 1 byte.
If you want to make it 8 to make the math easier and just take 1 more off the random, I'm okay with that. But keep in mind, this was 7 bytes and it was 0 padded. Like, so that was because this will go until like the year 10,000 when you're going to run into a problem where it's going to fall off, right? So,
okay. So now we have exactly 8 bytes of time microseconds, and exactly 8 bytes of randomness. And now we have to copy this like uint 64 pointer is pointing at UUID. And pointer is timestamp. So let's try to compile it.
One small question. Our chat, folks in our chat were concerned about OID for new function, because it's like, it should be like some manual signed number, right? And we should double check.
Yes, they are absolutely right.
Thank you, chat. Thank you, chat.
Thank you, chat. Yes, we need a new OID and check that it's not colliding with other OID. It seems like I generated randomly unique ID identifier myself. 1 bit of randomness, actually.
change the description. Change the description on that one.
Yes, you're right. And okay. And also we need a definition. We need a prototype for this function. Let's copy prototype. I don't see it. You having a prototype. Okay, maybe defining system catalog is enough. How do I get back my terminal here? Terminal. New terminal. So we can compile it again. We know that there are 16 cores. Duplicate it. How come they are duplicate? There is a Perl script to find
right
non-duplicate versions. Let's just try our luck. How come? I saw here.
Maybe let's use that Perl script, no?
I do not remember where it is.
I can try.
Let's try duplicate. Oh, yeah. Let's try to call it. We need not a duplicate dates. We need to find non-duplicate dates, unused dates. And let's pick this one. I like it most.
It's funny.
Where is our function here? No duplicate dates and compile. It's compiling for quite a lot of time for one small function.
Why do you redirect? We would like to see this, like,
because I want to see warnings about my code. Okay, I just created some very hacky C code that doesn't look well. In fact, these comments, for example, are not appropriate for Postgres standard. We use only multi-line comments because that's how things was in ANSI.
So we should see warnings for them soon.
This should be done by mem copy. This is not done by a pointer, but that's just how I done things.
So you are not approving your own patch already?
It's a draft. It's
okay.
You see, there is some. Yes, we simply lack. We simply lack enough. Enough header files. Where are they defined? We can just find it somewhere. Timestamp H. We need timestamp H. Let's copy definition to our oops. Yeah, now everything should work. No, it doesn't. Get time of day. I need what needs to be included to get to use get time of day. We got that from this function, which is including what? Systime. Okay, let's get systime. No.
Oh.
No. I just called it twice. It doesn't like that we are converting it to char. This is we can mute this by converting this pointer to PGUID. just before returning. Now, actually, no problems. Make install. And where is it installed?
You asked me already last time.
Yes.
I check this gitpod YAML once again. It should be in the root of the repository. There should be, like, if you go to the left, navigator on the left.
I think it's here.
Yeah, maybe. Yeah, pglocal, exactly.
We have binaries here, and that's what we want. DB new cluster. Start cluster. Okay, so now we can select our new function from, just select our new function.
Just select.
We see a lot of zeros at the beginning.
Do it again.
We have a lot of zeros at the beginning.
Yeah. Select one more time. Okay, so that's okay. That's enough. So what you're seeing now is the first three groups are probably all the timestamp portion, and the right two are becoming. Now we have extra zeros because in the original implementation, remember there should only be 1 0. We added an extra full byte here, right? Because we were playing with the difference in size. So the original
byte. Do you think this byte is important?
No, I think we can lose that first byte now.
Okay.
After I see it, I just didn't know how the code was going to come out of here. We can lose the first byte for sure. The leading zero is not a problem.
Let's generate series of 1000 of that.
So are we going to take care of performance now already, or what?
Yes.
Well, we're
going to
fix the output a little bit to get rid of the extra leading 2 zeros.
We don't need output. We need just to measure what time it takes to generate million.
Oh yeah. But I do select count normally to do this.
Yeah. I was just wrong. Count. So avoid.
And I usually turn on /timing, right? Or
timing. So now let's check what it takes for ULID, ULID, and for UUID. They are
very comparable. Nice.
They are comparable. That's true.
If you want to paste in the PL SQL code that I sent you, we could call that version of it to compare.
Somehow I was sure that syscall will eat our time, but it didn't. Can you explain a little bit what this SQL code is doing?
Sure. So what's happening is I take the epoch of the clock stamp, so I get that, which is number of seconds. I multiply it by 1,000,000, turns it into microseconds. Then I pad it to the left to make sure it's 14 bytes exactly, right? So it's 14 characters. And then...
may I say one thing, that hexadecimal character is a half of a byte.
Yes.
Nibble or something like that. So 14 characters is 7 bytes, actually. Sorry for interrupting.
Yeah, no, that's fine. So that gives me the first, when you look at it in hex, it looks like, that's the first more than half. And then I generate the rest as just the random bytes, right? Random bytes. Now, I don't think you can compile this, and you might want to change the name because, this is ULID 3. That's perfect. Yeah. So you can create this, but it might throw an error if we didn't install PGCrypto. We got to create the extension for PGCrypto.
Create. I think we didn't compile it, but let's try extension PG.
Yeah, we
it's
need
not
to
there.
compile
Just a
country
moment, I
models.
will. Just a moment. Contrib. We need PGCrypto. Create extension, and that's the only extension we have now.
That's strange. Should we load it to shared load libraries? We shouldn't, right?
Oh.
It's undefined symbol.
Make install again. No, it doesn't work for us.
We don't have to use that version of random bytes, but well, I don't know how else to get random numbers in there. So I just use the PGCrypto version. Is there a slightly different version?
Maybe we can have some other version of getting random numbers. Let's see where pgstrong random is also used. It's used in PG random bytes from PGCrypto, but if we don't use PGCrypto, where else can we get it? All this is not exposed as SQL functions, so we need actually installing PGCrypto, and I think we need to say something like apt-get install.
Right, there is a random, just the garbage random function that we could call just to get a number.
Get just some bytes.
Yeah, just get a random number and convert it to bytes.
Yes, we have just random, but it returns us numeric, I think.
Yeah.
How do we use it for?
For inside of this, we want to
replace some other way of bytes.
How about we just multiply this by a roughly an 18-digit number, right? Multiply the result by 10 to the 18, right? And then trunk it, right? Because it's 18 bytes that we're going to, or 9 bytes, however many bytes we want, and just convert that to. I don't care what the result is per se. It's not a fair comparison, though.
I just don't know how do we, is there any function to get byte array? How do we typically get a byte array? I'm not into SQL that much.
Usually I just use strings, right? Because that's the closest approximation to a byte array is a string, right? So we can convert a string to an array of bytes.
Oops.
Oh, the word replace is misspelled too, just at the beginning.
We need 16 bytes, something like that.
This needed 9, but yes, the word replace in the first line. Yep.
Replace, and then call this function.
Going to throw an error. The number of bytes is wrong. Change the encode A, B, C, D, E, F. Count out only 9 bytes, 9 characters.
9 bytes, 9 bytes or 9 characters?
9 total. Yeah, 9 characters. Same concept for me at this point. That should work, I think.
Yeah,
there you
it
go.
Works. Now it's not really random, but we can measure the performance.
Right.
it's kind of random because we choosing this number 1, 2, 3, 4 like randomly. It's just constant. It looks like it's faster.
It is faster, but it's because we're not making the function call to random, right? We just did it as a constant. We're not making a function call to a random number generator.
So if, for example, we store clock timestamp, it's if for example, insert happens with this function, and also in next column we also use clock timestamp, it will get the same value, and everyone who knows this this string, how that kind of random ID was generated, it can be predicted, right? If you know timestamp, you know the result here. So
yeah, and if you know the key, you can actually extract the timestamp, right? If you know
both directions.
You can recalculate when it was inserted. And that's the caveat. If I'm using this, for me, I don't care if you know when I created it, okay? I just care that it's unique and it doesn't perform badly or generate a bunch of IOs when I'm inserting millions of them.
Okay, I don't know what's wrong with PGCrypto. I can try to Google it.
Why we cannot install it, or what?
Yeah, why PGCrypto extension is not working?
Okay, Andrei is using Stack Overflow. Good.
Yes, I just
right.
Why not? Maybe we just need to install all other extensions. Maybe there are dependencies between PGCrypto and
I doubt, but we can try libraries or
install all libraries, all the extensions. Now we have only crypto extension.
PGCrypto is the only one that doesn't want to install.
Yes.
So here's regardless of which way it works, so we can't test it, the comparison we're making on this equal machine is basically that both of these are running in about the same time. They're close enough. Whereas in my tests, comparing it on my machine, it was basically almost twice as slow. It was 1.9 seconds versus 1 second to do 1 million. Okay, so and that's without inserting them. Once you start inserting them, the advantage is clearly to the ULIDs.
Let's try to create some indexes.
Yes, there you go.
For example, create table X UID U.
Yeah, do you have OpenSSL installed? Yes. Maybe dependency was OpenSSL actually. Right?
So what do we have to do? Create index on X U. Truncate X. Insert into X. Select. How these functions were called?
Generate. Yeah, gen random UUID.
U from generate series 1. Let's insert 1 million UUIDs. It will take a few seconds, I think. But like 3 seconds it takes to generate 7 seconds now.
Good. Now, well, create a new. I use 2 different tables, so I created like X1 and X2, so I could actually run them side by side without truncating them all the time. But it's good.
I think we just repeat it.
Okay, so now here, this is okay. Do it again. Do it again and keep adding to the table and you'll see the result. As you get 5 or 6 million rows, it really slows down. That's why I did them in separate tables.
Huh. Okay,
So,
let's do that. So we need
So
to
it-
drop table X. Create table X. Create table X. Create table Y. Create index on X. Create index on Y. Insert 1 million ULIDs to X. It will take like 6, 7, 8 seconds. Insert into Y ULIDs. First million will take 6 seconds. Next million into X.
yes, takes about, like I said, about 5 or 6 million for the pages to really start getting pummeled on the UUIDs.
9
But
seconds.
it'll slowly get worse.
Checkpoint 6 seconds. Almost 7 seconds actually. Nine seconds. 6 seconds. Yeah, that was interfered by checkpoint. We got 1 second from checkpointing.
Right.
I think so.
So, and that's my experience is that the ULIDs end up inserting at near linear. They don't increase as the table gets bigger. But look what just happened. You went to 11 seconds and you're just going to keep getting worse with UUIDs.
That's true. And we keep 6 seconds for Y. For table Y.
So you can imagine in places like if you're using Aurora and UUIDs and you have a large table that you're inserting into, you're paying for this because this is a ton of IOs at the end of the day.
Yes, but you cannot install your custom function into Aurora, but you can install
but if
SQL
it gets
function.
built in, right, you can get the SQL function, and if it gets built into Postgres, it'll eventually make it into Aurora, right?
Yes, they will just have it because Postgres have it.
But it's good for a regular as well. Now you're starting to hit, you see this, now you're at 13 seconds, and it's just gonna...
It's growing.
Yep.
6 seconds. Its difference is twice of performance now.
Yeah, it'll keep sliding.
And we explained how B3 is filled, right? Differences in B3 or
like you have, when you insert 1 million of random UUIDs, you have to basically touch all pages of B3. The bigger index is, the more pages you have to touch.
Yeah, if you do add and explain, add the explain to the front of this, do an explain, analyze, buffers. Yeah, I learned this from this Nikolai guy. He's really smart. Anyways, if you do this now on both of these, you're going to see a night and day in how much is going on.
Yeah, like in fact, we keep two seconds just to generate this data, and it is writing 3 million of records in 3 seconds. So this is a 4x.
Yeah, this is the X. So look at the number of buffers, how many were dirtied? 578,000 were dirtied. 576,000, okay, were written. Okay, yes. So now run it for Y. Add this to the next one and up. Yep.
It's like 4 gigabytes.
Yeah.
By the way, PSQL knows how to write analyze, but do not know how to write buffers. it doesn't have hints for writing buffers.
Buffers are disrespected in many ways. It should be default.
Dirty. Dirty.
Open your terminal, yeah, so you can see both. Look at the. I'll be curious to see when Nikolai looks at this. You know, what sticks out to you, Nikolai, when you look at this? Because you've helped me understand more about reading the buffers and the impact on these.
Buffers we should just convert to bytes, to gigabytes or megabytes. It's like each buffer is 8K size, 8 kibibytes. And the first one is 4.5 gigabytes and second is 71 megabytes. It's a huge difference. And I think actually we also chatted a little bit last week with Andrei, I think also, right? That it maybe someone else. It would be good to distinguish which buffers are associated with heap and which are associated with indexes. But I think it would be a lot of information.
Another session.
Well, but the problem will be how to make it still compact, because analyze it's still a lot of information, right? So
look at the number of buffers read in the case of Y. We read 12 buffers. And how many did we read on the case of X? 569,000.
All right, but I think it's explained by the size of buffer pool, right? We just
but I think that number that we're reading is actually us looking for each UUID in the B tree.
Yeah.
We have to actually do
through the password to install it, and we were searching through internet pages.
We have to search it all the time. Yeah.
And the second one was just descending rightmost path in a tree, never touching any old pages.
Right.
Imagine how it would be great to see which of those hits and reads happened with heap and which happened with indexes, which indexes, and so on. Like it would be great to see details here, but I'm afraid it would be like too much info. For maybe some experts.
Let's try it next time, maybe.
So
I would actually have it as extension at least, and use in some lab environments, not in production, maybe at least.
And look at, for me, the performance difference. You're already at 3 times, just about, right? You're almost at 3 times faster, and you're talking massive reduction in IOs just in changing how you generate this value. So
we could enable IO timing as well to see how of those milliseconds. How many of those milliseconds are associated with IO, right? Just because right now it's disabled IO timing.
How to enable it? I just don't know.
Let me quickly recall it. I will go to postgresql.co.nf, and it's track. I think track IO timing. No. I mean it's a GUC, GUC. Track IO timing, I think. Yeah, track IO timing. Set track IO timing to on. To true. Okay.
yeah, let's do X first with the explain. So we're doing them in order. Yep.
It's on by default. Yeah. Ooh.
I think it must all be IO.
Except
2 seconds of generating random numbers.
Yeah, IO timing is.
Do you see anything here?
Yeah, IO timing.
Actually got a little faster.
It's just deviation. It's not a like systematic.
Checkpoint happened also. We had checkpoint.
And maybe vacuuming, something like that.
So do it for Y, and let's see what the difference is. Let me explain. Good.
Do you see anything here? I'm
You mean
really looking too often.
Well, we see that IO timing in this case was like very small in the second case, right? Because the whole time is this execution time, but for writing, we just for temporary files, temporary buffers happened also. It's small, relatively, right? So majority of time was spent not for I/O in this case. But here we had more than 1 second spent for reading. Again, it's also like we expected majority for writing almost 3 seconds, right? So total like roughly 4 seconds out of 13. So again, it's not the majority of timing seconds. Interesting.
And again, so it just confirms that in this case, the slowdown is all I/O. It's not CPU. It's, it's not hitting anything else. It's not really doing more work except for when it deals with the index, because if you drop the index, this problem goes away.
They should be very similar with index, right? Right.
Yeah.
And I wonder, there are several articles comparing regular sequential integer primary keys versus UID primary keys and so on. I wonder if they consider ULID approach as well. I should double check. I remember several articles about it. So interesting. So what do we do with next with the patch?
I think we submit it.
Who? Not my turn.
I don't know.
Andrei hesitates to submit such small patches.
I can submit it if we have a documentation that this is a standard. If maybe I should just implement UID v7, like v7 is a standard. It's acknowledged as a standard. If it is, I just will implement this and put all the bits as they should be. But I just don't know where to get a documentation. What's in standards there? Send me a documentation. I will make a standardized implementation.
Okay, I will grab the UUID 7 documentation for you and get that off to you.
Great. Let's try to go that way and try to make a real standardized production ready to use implementation of whatever those folks standardize.
Before we submit, right? Before we submit, we improve. Okay.
Yeah.
Makes sense. Well,
okay, so it's kind of time to wrap up, I think, because it's like 10 already here. Time to get to
we definitely it's about 1 hour already for our stream. Thank you so much, Kirk, for the idea and for participation. I enjoyed it. It was great.
Thank you. It was very interesting topic.
Yes,
thank you.
Let's see what we have in future about this. Thank you so much, everyone who watched this online. We had a few folks and participating in chat, especially great to have
that help with OID actually was very helpful.
Right. So and of those who watch recorded, don't forget this is the right time to subscribe if you haven't yet, and also please put like to this video and share with your colleagues, because maybe someone will learn some basics about hacking and also consider contributing to Postgres. Thank you guys. Let's meet next time. Bye.
Bye.